in our chat today and on the phone, and you'll hear from them throughout the dive, but we will introduce them in a few minutes as well. Another very important partner is the Global Foundation for Ocean Exploration. They operate and maintain and upgrade our vehicles, the Deep Discoverer and the Sirius, as well as provide the outstanding imagery that we're getting from our videographers. Okay. Patty is chomping at the bit to get going here. Really, 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 really different, huh?
Huge
really
boulders
different
at the base of this slope.
Okay, and let's see. Pilot, whenever you guys get comfortable and you would like to introduce yourselves, we would love to have you introduce the ROV team and our videographers.
Yeah, we're still getting set up here.
Roger that.
You want me to come up a little bit?
Yeah. So where do I need to go? Just push forward?
Yep, straight forward.
Wow, check this out.
I know, I am.
Look at these big blocks.
Didn't want to
Look at these
interrupt you,
blocks.
hon.
Look at these big blocks.
Smokes.
Oh my gosh.
When we get up to that steep part of the slope, it's going to be quite a sight to see.
So
this is material that has just, I mean, absolutely broken off the slope above us, tumbled down, collected here. There's quite, I'm surprised by how much sediment there is on top of these blocks. But normally you see smaller pieces of sediment.
Check out the view from Sirius.
Oh my goodness.
I think it's on feed 2 for those of you at home who are following along.
This video, the center one down the bottom of your computer screen, gives you a view of the D2 ROV from the vehicle that's above it, attached by a 30-meter cable. And we are looking at enormous boulders. In fact, the only other place I've ever seen anything of this size is near the Challenger Deep when we were diving in 2009, with Woods Hole's Nereus vehicle that could go to 11,000 meters. This is 4,429 meters, and I'm guessing that much of what we are looking at are blocks of material that have fallen off the steep slope that we will be ascending toward the middle of this dive. And they are incredibly angular, and the exposed surfaces are dark, not like what we saw in the first broken subducting seamount that we dove on a few days ago, where layer after layer after layer of 100-million-year-old reef deposits were exposed. This material, unless it's completely covered with a black manganese crust, does look like much more massive, perhaps
bring up the quad stream
massive lavas or intrusive igneous rock. But we'll wait. We'll see when we get to the exposed slope whether there's also reef material, which is what you'd expect on one of these flat-topped ancient seamounts, ancient volcanic seamounts on the Pacific plate, just to the west of the trench axis.
A little far out there.
Holy smoke!
What would Chris say? What would Chris say? Holy guacamole.
Holy schlamolians.
Holy schlamoli.
I'm a Roger Rabbit fan.
All right, watch lead. We're all set up here.
Okay.
That's great. How about introducing yourselves? Oh,
this is Joshua Carlson. I'm in the pilot seat for today. And to my right is Levi, who is the co-pilot for this shift. And to my left is Jim Newman, who is the navigator for this shift. And we're all with GFOE, the Global Foundation for Ocean Exploration. And then we'll allow video to introduce himself and the clipper.
This is a video engineer, Roland Bryan. You see me way in the far corner, and in the rear we'll have Tara.
Right,
say hi, Tara.
Hello.
Okay.
Ooh,
here we are.
Watch lead
Thank
pilot.
you very much.
Go ahead.
When you're finished zooming on the sponge, which is lovely, there are some columnar joints at the bottom of this boulder that we would like to take a close zoom on also.
Absolutely.
Oh, jeez.
Yeehaw.
The heck?
Looks like a beautiful sponge.
Take
Right?
your
It's
sonar
an
in there.
absolutely spectacular
Nice.
sponge.
Wow. So what
Hexactinellite. I'm waiting for our Hexact specialist to tell us.
Okay, folks.
You're going to wait a long time, Shirley.
2 seconds is
This is another new one?
of latitude. So we're on.
I've not seen anything like this before. I don't know what it is.
This is one of the phenomenal things about these expeditions, folks, is we get down to the bottom of the ocean
I
and
got you at 10
we
meters.
see something no human eye has ever looked at before. This is possibly a new, previously unknown sponge that our most august sponge expert, Shirley Pomponi, sitting next to me, is looking at and going,
You can come in tight again.
Yeah.
Levi, I got one last question.
Yeah.
On the high pack.
And Chris, I'm just hoping we see this in a little while because
How do I see?
don't want to take up our
serious
two
depth?
organism spots right at
So
right at the
on
beginning.
high pack,
Yeah.
our sampling is
I see the ROV
very
position,
limited
but I
on
don't see
these
serious
dives.
as
We
a-
do
I
two
don't see
geologic
it's,
it's on high pack. It's
two
like a
biologic
little.
samples. So
on high pack?
Yeah, if
Oh,
you
I
We're being
just shoot it on high
judicious.
pack.
Yeah,
Got
yeah.
it. Got it. Okay.
Got it? Okay.
What's that video?
It's just too much oscillation in the image.
Yeah. I'm sorry, I can't really sit down.
Chris, hopefully we'll have some
Must be
good
better
video
partially
from which we
zoomed.
might be able to get this down to subclass, maybe. I don't know, not without spicules. Okay.
Wow.
Okay.
All right, come on out.
Full wide or partial?
Just to get the specimen.
Okay.
The
That's good.
other thing I noted is there's dike rock below it, or columnar basalt. I think you saw that too, Patty. Would that be in your interpretation of those angular formations at the base of this boulder?
Absolutely, Chris, and I've already have a call into the pilot to take a close look at those. Oh yes, oh pilot, yes, we want to get a zoom on this as well.
So, Patty, is one interpretation of this kind of surprising result here that we got right off the bat is that this seamount cracked open to the extent we actually got into the volcanic top of the seamount, and that as we go further up, then we'll get into those similar white chalk Cretaceous lagoon layers.
That is exactly what I'm thinking, Chris. Good for you. A+ for geology today. And I'm wondering if there's ever going to be a small enough piece to pick up, because these are the biggest boulders I've ever seen. Beautiful. Look how angular these are when lava is not erupted on the surface, but rather is intruded underground in a crack or as a very thick lava flow. As it cools, sometimes it creates what we call columnar joints, and these joints are fractures in the rock. And from the surface, these will look just like mud that has cooled in mud is dried in a puddle, and so you get sort of a hexagonal surface on the cracks, and then in a lava flow or in an intrusive igneous or intrusive magma body, the same sort of thing happens, except that those cracks go all the way through the either lava flow or intruded body of magma. And what is left is just like Devil's Post pile.
This is very cool. We just saw another stalked sponge,
really
hexactinellite sponge. So this is good substrate upon which these sponges can attach. Yeah. Wow. Very cool.
And it's hanging down.
Yeah, so one of the things you'll notice since we just did another geode dive that was on the top of a geode, and also this lends support to the idea this came from the interior, is the fact that you see virtually no manganese crusting on these rocks. These look like almost pretty clean basalt exposures. And would you agree with that too, Patty? That was one thing I was looking at, and to me that suggests that this thing fractured so recently that there hasn't been time for the manganese to actually build up on it.
It's a partial.
I suspect that you're right, Chris, that there is some manganese. If there's any manganese, it's a very thin coating. But, as you know, when we zoom in, we usually do see some manganese on the rock surfaces. But we'll see. Maybe, if we can find a loose rock and bring it back, we'll certainly let you know as soon as we can. But you do see a roughness on these surfaces rather than a smooth surface with cauliflower sort of
botryoidal.
Yeah, I know.
I love that word.
Shirley's learned a new word, which is using
one. Yes, frequently.
Oh, one word? No, we've all learned lots of words for new things we've never seen before. That's the thing about this sort of expedition. You get down to the seafloor and you see something you've never seen before. And if you think about that and the fact that 70% of our planet is so poorly explored that can happen.
So, Patty, do you think there's going to be a rock maybe a little bit further down that may be
I haven't
loose?
seen any yet. With talus piles with materials as huge as this, you might see the smaller rocks a little further up, but we are looking at another sponge.
Yeah, another hexactinellid sponge.
Is this one you've seen before?
I think it is. It's
a little white creature in the rocks.
Certainly looks like the other one or two that we just saw just a few minutes ago underneath the rocks.
Under that ledge where the columnar jointing was.
What sponge?
Great.
Oh,
look if I bring your port lower in just a little bit.
It has a collar.
It does.
Okay.
Just to match the other one.
Wow.
Okay, so this is a glass sponge.
So this is made of silica.
Josh, can I recommend?
That's right. So the spicules are made out of silica. That's right. So these sponges have microscopic skeletal elements.
More than
I'm settling on the bottom.
That are made out of silica.
So
is this silicon dioxide?
Yes.
So that's the same as quartz to folks who don't know the mineralogy.
We're going to go ahead and get a look down the stalk at the base of this sponge as well, because sometimes the way these sponges are attached to the substrate can be diagnostic as well. Chris Kelly, who's actually capstone lead scientist from the University of Hawaii, has become quite an expert in hexactinellid sponges. He's worked with one of the masters, Henry Ricewick, Dr. Henry Ricewick from Canada, and has gotten to be
get that other creature.
Gotten quite a level of expertise in hexactinellid sponges. These are notoriously difficult to identify if you've been working like I have mostly on demo sponges, another completely different class of sponges.
And Shirley, what is this teeny little thing that is being looked at right now? What is that?
I don't know. I have no idea.
Anybody on shore know what that thing is? Tara Luke
says, what is that? Yeah, I don't know.
We see stuff all the time that we've never seen before.
I don't know if we can zoom in on that or not.
I think we're about
it might be max zoom.
We
might be max zoomed.
Yeah. Pilot is moving the ROV a little bit closer so we can take a look.
Yeah, I don't know.
It's got, I don't know what it's got.
So Chris was saying that the sponge that we're seeing is euplectellid, possibly bolosoma of some kind. Yeah, Chris, I was just looking at the chapter that you contributed to on the sponges from the Hawaiian Islands. And oh, there we go.
What is it? It has legs?
Well, it has kind of spines.
Okay. and it's sort of a little purple around the edges.
I don't know. Is that it? Is that
We don't know,
if it's
what
a pteropod. I have no idea.
It kind of looks like a pteropod. I was scared to say that, though.
No it's definitely very small.
It's really small. Any ideas what that is? Anyone on shore? Okay. Looks like a shell. Deb says, is that a shell? Looks like one.
Back of a pteropod shell, says Scott France.
Oh,
good.
Right. Yay. Okay.
Good.
All right,
evening,
that's
Scott.
good. Okay, so we
better get moving.
We better get moving. We have joining us, because through the magic of telepresence,
Yes.
the two of us who are the ship-based scientists, along with many others out here on the ship who are scientists but are doing other things on this this expedition. We are joined by experts from all over the world, and you will hear from many of them during this dive today. We have from Japan Asako Matsumoto from the Chiba Institute of Technology in Japan. We have Chris Kelly, from whom you've already heard, and Chris is heading up this capstone campaign that's been in effect, I think, for about a year already. He's at the University of Hawaii. Debbie Blaney is from the Office of Ocean Exploration and Research in Silver Spring. Deb Glickson is from the from Florida Atlantic University Harbor Branch Oceanographic Institute. She and I work together very closely in directing the NOAA Cooperative Institute for Ocean Exploration Research and Technology. She's my most valuable sidekick, and she was the geology science lead on leg one of this expedition.
And a great one she was.
We have Scott France from the University of Louisiana at Lafayette. We have Tara Harmer-Luke from Stockton University in New Jersey, and we have Tim Shank from Woods Hole Oceanographic Institute. And my guess is that we will probably have Tina Molitsova joining us shortly from the P.P. Shirshov Institute.
Back on 090.
In Moscow, and I'm trying to think of who else has been joining us on a very regular basis. Bruce Mundy, maybe, from NOAA Fisheries.
Yes.
All right.
Wow.
So quick introduction to our shore-based collaborators.
And folks who are watching us onshore, we are at the base of a huge fault-controlled wall on the seafloor on part of a seamount undersea mountain that is quite close to the Mariana Trench axis. This seamount is in the throes of being subducted. The plate on which it sits is moving down into the mantle at the Mariana Trench. And what we are seeing is kind of surprising, because we had expected at the base of this steep slope to find small fragments of rock as piles of what are called talus, just broken up pieces of rock.
Okay, what is that a fish? Oh my gosh.
Perfect, thank you.
I think it is.
Oh my gosh. Is that the same thing? Wait.
No, it is not a fish.
It's not.
It is. My
looks like
favorite animal.
it is. It certainly is.
It's a holothurian. So cute.
Now, this is kind of cool, the way it's swimming, because it is. It's certainly unusual for anything I've seen. It's kind of like hovering. It's like hovercraft
floating down
above the bottom and now settling down, because we've seen these holothurians kind of like rise up, kind of go up vertically in the water column, just slightly above the bottom, and then come down and land on another area where they feed on the sediments, all the nutritional value of the sediments that are down here. So this one looks like it hasn't fed for a while. It doesn't have a whole lot of sediment in its digestive tract.
And
very
it's not going to find very much on this big boulder, but it'll give it a try.
This is very, very interesting. Okay, any of you on shore, do you remember seeing anything like this on an earlier dive?
So
Pilot, if you're able to zoom in any more on this, that would be great.
Coming in on it. So, Levi, you need to be very cognizant of the sonar on this.
Yeah.
And we want to avoid bumping Sirius into a cliff.
Yeah.
at all costs.
Terra Harmer Luke says she doesn't recall seeing anything like this on any of our dives on this leg. Deb, do you recall seeing anything like this on any of your dives during leg 1?
No, but I also haven't really been able to see any of its, like, feet area. I don't know what they're really called because I'm a geologist.
Yeah.
But no, I don't really remember this.
This is very smooth. It doesn't have, or at least it's not expressing
there's like tentacles that we see, and it's
projections all over its body.
Really,
that we've seen before.
And the ones in the in the front seem to be fused into just a single. Not sure if we call that a mantle. Okay, so there you can see some of those tentacles now.
Well, maybe they just hold them back when they are swimming or settling to
this one looks like it's kind of
aerodynamic properties.
You know what? Scott France is saying that he's not even sure it's a holothurian. He's wondering if it's an out-of-place heteropod.
Which is?
Yeah, we don't see any twisting intestine. The organ system doesn't look right for holothurian.
Okay.
You know what? You're right, Scott.
And what is this then for folks who don't know the technical terms?
I'm quickly looking it up.
All right. Heteropod. That means hetero. Well, I know pod means feet. Digging back to high school Latin, hetero means different. I hate to say this, it kind of looks like a tunicate to me.
Yeah. This a heteropod. It is a taxonomic superfamily of sea snails or sea slugs, marine gastropod mollusks.
Anything related to a
commonly called heteropods or sea elephants.
Okay, where are the ears?
Did we get lasers on this?
We will once we come out.
Gosh, here we go again, folks.
All right.
Something we have not seen before on this cruise. At least up this leg.
All right, when you're clear, video.
Nice, very nice. Okay, I think we can proceed upslope.
All right, coming up.
That good with you?
I think we really better.
This happens more and more frequently.
Once again, we are being distracted by the beauty of the environment. Wow, more very angular fractures. Wow, Chris Kelly, who proposed this dive and who, like all of us, thought we would be looking at reef deposits in this deep exposure of the wall of an ancient seamount. Oh, there's something in the water. Look, it's one of those firework display things.
Oh, no. It's like that thing that we've been... Is like the one we saw in the mid-water the other day?
Yep.
No, it's not. It's a swing. It's a... Looks like it's an isopod. Beautiful.
Isopod with
beautiful, beautiful.
But a very nice view.
It's coming towards you.
Oh, really pretty.
Inside your lens.
Really pretty.
Stabilized. Pulling out.
All right. You can let him go. If you're good, video.
Yep.
Okay.
Go ahead, watch that. We need to be off the bottom at about 14:30, 14:20. I'll do my best.
Okay, so this is another hexactinellid sponge, different from the two others that we've seen.
On this dive.
On this dive, yes.
But we have seen this one before, I believe.
Could be related to maybe Faria. I'm not sure. Boy, I'll tell you what, kind of resembles the Afrocallistes that we see in the Gulf of Mexico, a little bit in shape. But yeah, Chris, want to weigh in on that?
Yeah, I'm punching something into the chat room right now. I think it's going to wind up being a euplectellid.
Oh, really? Wow.
In the Corbitellinae group, because they tend to have, at least some of them have these lobes coming off of the side.
Cool. Very cool.
Ooh, interesting rock behind. Look at
very interesting rock.
Look at the curved features right to the right of the sponge. Ha.
Okay.
Curious.
All right, so we have
and an angular shelf to the right.
As our mappingly pointed out, about 630 meters along this dive track, maybe more than that we need to traverse during this dive. No?
400.
2256.
400, oh, okay.
410.
Oh, good, all right.
Yep.
All right, 410. I thought he said 630.
Whoa, whoa.
Correct.
Oh, my gosh. Oh.
Shirley goes to write something down and pops a sponge.
Like
her favorite beastie.
It's like 2-year-olds. You can't take your eyes off them for 2 seconds. Oh, my gosh. Chris.
What is this? I haven't seen a sponge like this yet.
No.
At all. On any of the dives. Even leg one. Let's see. Maybe Diva. Is Diva on?
Not yet.
Not yet.
So we're just about to finish this move by the ship.
So I think this is probably some kind of uretid or Faria. These are what we call hard sponges because they tend to have a fairly brittle skeleton as a result of cross-linking of the spicules, the long skeletal elements of these sponges. Yeah, this is a brand new one on me, and I'm biting my lip. But boy, this is a fossil dive, and you know, I sort of like to reserve some of the collections for fossils.
Yeah, we're not. Notice I'm not pushing. Yeah, we're gonna start moving up now.
I'm sure you know that
we hope.
There.
Yeah.
Unless we see something.
This is painful because I've never seen a sponge like this before. So
I know.
Yeah, I'm bleeding over here.
Me too, Chris, because these rocks are just too big to pick up. They're bigger than the ROV. And folks at home, when we're talking about sampling, we do have limits on what we what we customarily take on these dives. Biogoo in the water, which doesn't look interesting.
Nope.
We don't want that.
All right, let's go ahead and start moving up.
Yep. So the ship has just started. The Sirius has just started to move.
Okay, great.
Fantastic. So what happens is that the ship will move on the surface, and that will draw the vehicle that is giving you the view of the ROV, the Sirius, which is attached to the ROV by a 30-meter cable. And the ship has to move Sirius forward to give the ROV enough slack to move around and view things on the seafloor. What's fascinating about this giant boulder we're just going across is that the vertical side of it has angular fractures on it, which are quite striking.
And light to moderate sediment on these.
Not very much.
Not very much at all.
And what that suggests is that they haven't been sitting here for a long time in order to accumulate a thick layer of sediment.
On the way up, we can come back and look at it while you continue to swing. So
Deb says, so far these massive rocks look igneous to her.
They do look igneous to me too, Deb. I'm with you. Even Chris agrees. And he's looking for coral.
It's supposed to get a lot steeper second half of the dive.
Yeah, absolutely.
But
it's probably going to be in place.
Well, I mean, some of these geodes are pretty solid. Like there's another one just to the north of this one that has a lot of secondary cones on it, it looks like.
Yeah.
So it's possible that we've arrived on one that is primarily really solid volcanics, I guess, but you'd still expect some kind of layering from old Cretaceous shallow seas.
Well, we shall see.
Right, we can probably put in. So 30 should take us.
Oh wow!
What to that return right
as we rise up this boulder, the Sirius view gives us a look at the size of it, and the size is maybe 5 or 6 times as wide as D2, our ROV, and the ROV is a little over 2 meters wide.
Yeah, wide, I think. Yep.
Gigantic boulders. Very angular. This piece in front of us, in the middle to bottom part of the screen, the smaller piece, looks like it just broke off the rock next to it.
I mean, the wall will be able to go up.
So it looks like we have a fairly large area. Okay, so how far away is that?
You know, I'm not sure what the divisions
what the scale is on that sonar,
yeah. Folks, I'm looking at our sonar display, which is in your quad screen. That's the image or the feed on the far right of the 3 on the bottom of your screen. And on the bottom right corner of that are 2 circles.
Go ahead.
And those 2 circles show us the sonar imagery for, on the left circle is the remotely operated vehicle.
10 meters out. So nice.
So the bright
10 meters at the maximum.
Yellow and green.
For D2, watch lead. No, that's 10 meters all the way out.
Okay, and so we're looking fairly close. To, 10 meters from the central horizontal line to the edge of the circle. That's 10 meters.
Almost a tenth of an hour.
So 2.5 meters for each of the divisions.
But it can get really steep.
Come on out, video.
So what we're seeing are these hard returns on these big rocks.
We are
from these big rocks.
Right.
Sorry.
Okay.
I think so, yeah.
So as we fly over the rocks, then the sonar doesn't catch a return from the next one because it's more than 10 meters away.
Bearing 090.1 knots.
Oh, wow. What you can see on the bottom left of the screen is the bathymetry data. So this is a map looking down from above at the seafloor, and the lines, the curving lines that you see on that map are lines of equal depth. So these are, we call these contour lines. And when they are far apart, that means that the slope is relatively flatter. When they're very, very close together, that means we are looking at a steep scarp. And our track is going to take us up pretty much the steepest scarp that we have seen on this dive as yet. Oh boy, I would love to get a rock if I could find one small enough that the claw might be able to pick up.
So we have been joined this morning by Gene Ranke, who's a professor of geology at the University of Kansas, and I know he's quite interested in the sediments and also fossils, if we get to that point.
Can we come down a little bit?
Yeah,
thanks for joining us, Dr. Ranke. And Tina Molitsova, as I mentioned earlier, has also joined us from the P.P. Shirshov Institute in Moscow. Who else?
And I believe we're looking at a sea star. Is this a sea star like those we saw? Yeah,
looks like it. Looks like it.
We have seen this guy.
And it looks like it has a little polychaete on it.
Yeah.
It has a little polychaete on there.
And we have seen lots and lots of them.
That's good, pilot.
When you're clear, video.
Interesting that this boulder, where it is exposed, looks different from the more angular ones.
Right, coming back up. Let's do a snap zoom.
This rock looks very different from what we have been looking at before. It doesn't have that same angular fracture. The surface is rougher, more nubbly, if that's not a geologic word, but it works. And the exposed material is lighter in color, suggestive of a different rock type. Chris, this does look more similar to the manganese encrusted coral and reef deposit we saw on the first exposed part of, or the exposed part of the first geo that we looked at. Oh yeah, for sure.
We can come in.
Okay, so what's that brown stuff now?
Yeah,
Good question.
Okay,
Good question.
Chris. Go ahead, Chris.
Yeah, no, I would agree with
Okay.
Patty. It's certainly looking a bit more manganese crusted here, and with some of this other stuff on top of it.
Okay.
So maybe some of this rock came off of closer to the top of the summit of this thing. I imagine you would get rocks coming from all over when it happened. The events that created this jumble of huge boulders. I assume rocks could be coming from all over the side of it.
Yeah, this is a guess, but some of the things exposed, the black things exposed in what we're looking at right now, do look angular. And I'm wondering if this is a mixture of blocks of igneous rock and reef debris that have commingled in a talus slope at the base of the very steep wall that we'll be getting to soon.
Come on out.
Sure looks like the brown stuff is very different from what we saw further down the slope. And yet,
So not just something that would be on the
boulder.
surface.
Maybe not. Not sure. Maybe not. We'll probably be able to tell as we go further up the slope.
Okay, and we shall.
Ooh, I look at these tantalizing rocks that are sitting in the sediment, but these are between some of these huge boulders, and I'm guessing they would be beyond the reach of our remotely operated vehicle's mechanical arm, because the pilot has to nestle in between these boulders, and that really makes it hard.
Okay, so do we want to spend time trying to get down there, or do we want to continue
No,
moving up
I
slope?
think we want
okay,
to
let's continue moving
moving.
up slope, because we are
Yep.
just at the start of our
I
first
agree, we
waypoint,
are.
and we've got a long way to go to get to the base of that
That
steeper
vertical
slope.
wall.
Get this thing in the water. Is that a fish? Yeah,
We have a teeny little fish.
way out there.
Here we go, with a black head and a white body. So, our fish experts
Try to come
on
down here
shore.
closer.
What is this guy?
Copy that tracking focus.
It'd be kind of hard, I would imagine, to
It's very small,
really
maybe
small,
20 centimeters long.
if that.
Yeah.
Yeah.
So I'm pretty sure, I guess I'm the substitute for Bruce until Ken occasionally calls in, but I would suggest this is a small Ophidia, the custial in the genus Leucochorus. It's got that very distinctive white color and sort of gray head.
Can you come down a little bit? Or no, you can't really. I'm just way out there.
Yep.
Halfway, ship's halfway through its move.
Our fish experts tell us that things that will help them to diagnose this to a better identification would be images of the head and the scale pattern, what's happening with the gills, the pectoral fins. It's really hard to do on these teeny tiny fish. And of course, This one is cooperating a little bit by staying still, but we are zoomed in.
The red dots that you see are 10 centimeters apart. So this little fish is maybe
they're a lot farther away.
Including
yeah,
the
we're
tip
a lot
of the tail.
yeah, but we're a lot farther away from it now too.
Okay.
The lasers are way beyond.
Yeah, the fish is further beyond those laser dots that we can just see kind of as blurs on the screen right now.
Well, I was figuring, you know,
nice.
the center of the dots.
Yeah. Okay.
Yeah, maximum 8 inches, if that.
Looks like there might be a parasite or something attached to it as well.
Partial.
Looks like one of those little leeches.
Yeah.
That we
looks
see.
Like, there looks like there may be 2 of them on there.
Yep.
Like attached to. No, it's further back from the gills.
No, it's attached right behind the stomach area.
I'm starting to get just a little closer to you, pilot. Not very fast, but.
Oh, boy, that's nice, Josh. Really nice.
Sonar
snap in on its face. See if we can get a super close up.
Just snap in on its face.
No, it's coming above me. Okay.
Okay, great. Thank you very much.
Max wide.
Copy.
We like to get their faces. Not only are they cute, but it really helps the ichthyologist to identify the species.
So this was, great video.
Rock.
Okay.
Maybe 33 meters.
Okay, the rocks now are much rougher surfaced. The ones below were smooth and had angular fractures. These rocks, although they do not appear to have a whole lot of manganese oxide coating, do have more manganese oxide coating, but have a very rough, rubbly looking surface. So it looks like we're into something different.
We can do another one, I suppose.
Here.
Be interesting to see what happens when we get up to that base of that steeper incline.
Right.
When we're complete,
So
could you please put in the identical move? 30 meters, 090, and .1 knots.
So at the depth we are now, we are a little more than halfway across the smooth part of the transect of our track. Okay. So about halfway up the talus slope.
Pretty much on target in terms of the time.
Lobster. Squat lobster?
So, pilot, I got a hard return dead ahead of me. I want you to check out pretty soon here.
Next soon.
Oh, Tara, you beat me to the punch on the ID for this thing.
See over it or not?
And the rock it's sitting on is definitely brown underneath and not gray. So
sorry, Patty.
That's okay, Tara. We have exactly the same time.
Yeah, I do not see over it.
The people on shore actually,
30 meters
those
out.
especially sitting in the expedition control centers, have huge screens and can look at this wonderful high-definition video. They do have a bit of a time lag from a couple seconds to maybe 10, maybe a little bit more than that.
Okay, thank you.
I'm sorry?
Co-pilot.
And so what 20, Shirley and I see
30.
on the ship is a screen that is like, I don't know, 50 inches diagonal, but it's about 9 feet from us. So sometimes the pilots and the videographers
I cannot see over it. And every scan it is getting closer to me.
And you at home. And you and back.
Oh, yeah, that's what I meant.
30 meters out.
Because Tara saw it before I did, the squat lobster.
Sounds like a plan.
Yep. The brown material exposed here is definitely not the same kind of thing we saw at the very bottom of the slope.
So we're just coming up watch lead to get a look with the sonar. and then we'll come back down.
Okay, thank you.
I think it was probably just that rock.
Yep, looks like it.
Okay.
All right, we're good.
Yeah.
Let's come back down.
Nice fracture in this rock. Curving down across the surface from upper right to lower left.
Oh, I was
Which is not surprising since these things probably fell from quite a height. Cracked on contact with the seafloor beneath the scarp.
Okay, so Patty, let us know when we need to zoom in and get closer images of the rocks. Otherwise, I think
I think we should keep going.
We should keep going. We really should keep going. We've got some very good images and some ideas about what we're seeing. And for geologists back at home, Deb and Jean, again, please make sure you let us know if there's anything that you need to get a closer image of.
17-meter delta.
Any of these look interesting, Watchley, for rocks?
I don't know. I didn't see it.
Well, we have a lot of sediment piled up at the base of these rocks. Sort of what we'd expect.
Go ahead, Watchley.
Watch that port swing around.
I don't think science was listening to you ask that question.
We pretty much need to, and we will be doing that as long as it's safe. But it's not clear. When it gets really steep, I'm not sure how we're going to manage it exactly. Right. No, we need to basically the time we have to get to the end point horizontally requires that we move continuously.
Let's get this white guy here.
Uh, 23, 24. Sponge.
Another hexactinella, a stalked glass sponge. Similar to the ones we saw a little bit earlier.
Come on up. Who's that white guy in there? Come back in.
Not sure. Yeah.
Tiny little white thing.
Tiny little white thing.
Yep. The rock above it, though, is brown, which is more typical of the reef-type deposit that we saw in previous dives.
Is that on the rock, or is that in front of the rock?
I think it's something floating just barely in front of it, attached to the rock, though.
This actually also gives you a view of the rock surface as well. A little bit. I know there's been some discussion about what we are looking at, whether there's some reef material in here or not. Not sure if that view helped at all.
Oh, that's a fish.
Oh, we have a fish. And
Right, come on in. that.
Ah, nice.
Watch my tether on this.
Yeah, copy that.
Just don't want to scrape it on the rock.
Yeah, it's nicely floating up above you. Happy?
Alright, come on in.
Tiny eyes.
Tiny eyes. Good view here of the scales on the head, of the gills, of the pectoral fins.
The shape of the head is important too, right? Now, if it would just turn sideways.
Okay, Chris thinks this might be a Basocetus. Perhaps, not sure. Sako Matsumoto is saying this view is fantastic, both biologically and geologically. We're at a little bit shallower now than 4,400 meters. We are at 4,394 meters. Wow, look at that. Beautiful.
Yep, but he's mostly stable.
This one doesn't look as if it even has gills.
But it does. But it does.
I'm sure it does. Has quite a long mouth.
Right in front of those pectoral fins. Okay.
Partial.
Great, thank you. Thanks, pilot. Thanks, video.
Okay, just let him go out, and when you're ready, come full wide.
Bridge, what's our distance to the end of this move, please? Thank you. Sort of 5 meters out. You want to tack on another move?
Well,
not yet.
5 meters out plus another 20 minutes of delay. How far back are we getting? So we're about D2's length, somewhere around there. I don't know where the center of that is.
D2's length.
Like, I'm trying to judge, because D2 is about where the layback is.
Okay, I see what you're saying.
Yeah. What I'm trying to avoid is getting like 60 meters of layback.
No, I get it.
Yeah.
Most of the fish that I'm recognizing that we've been seeing have been different species of these cusk eels. That's
come on in.
Polychaete.
That's what we were just looking at. What is that? Yep, very pretty polychaete.
And you can see it's got coiled about in the middle of its body.
You okay with that, pilot?
This one is full.
What do we have in sonar?
Yeah,
my
beautiful
sonar looks pretty clear, but I'm also
very
pretty far away.
Tara, here's another one for your
extremely hard
deep sea biology class.
I can see
show some anatomy in that.
30 meters ahead.
Pretty stable.
Our scientists on shore have been remarking at how these are
almost
all of these dives are rolling marine invertebrate zoology classes. And Tara Harmer-Luke
fins at the top
mentioned a few days ago that what we're seeing here, of these animals, right alive and in place, exhibiting different behaviors, makes it a lot easier to teach teach our students about these organisms, how they're adapted for life in the deep sea. Right now we're seeing some good examtions of locomotion.
I can't tell if that's a cliff behind me.
And anatomy as well.
Okay.
Okay.
All right, I'm going to push out. There's that fish again.
That was our fish.
All right, we're done our move.
Okay. Sonar looks good. We can probably tack on another move.
Yeah.
You okay with another 30?
Yeah.
Yep.
Bridge nav.
Get this guy.
Another 30-meter moves, please. Bearing 090.
Looks like another one of those with
the isopods.
the isopods with the long legs.
Yep, we got one earlier, right? Yeah. Didn't we? That's the second one.
Maybe it's the same one.
I doubt it. I doubt it. But it's good to know there's more than one.
You never know.
Oh, wow. I don't know what to say about that boulder. It does have some angular fractures, but it is ginormous. I'm so impressed with the size of these things.
I know. I keep thinking I'm like close to the bottom, but I'm like nowhere near the bottom.
Look at the sonar screen.
You mean because they're so big, Josh?
So
is
big,
that
yeah.
Our pilot is
so
saying
cloudy?
he's thinking that he's so close to the bottom because of the size of these rocks. I mean, they're just so big.
Well, not only that, if you look in the sonar image, you can actually see these giant blocks as individual returns, and they are only 5 meters in front of us. So, whoa, 15 feet.
Patty, would one of these rocks actually work as a collection, or are they on the move and can't stop?
I'm not sure whether we're on the move.
Can we collect one of these?
Yeah.
Yes?
We could?
Which one do you want?
Which one do you want?
Any of these would be fine, pilot.
Geologist onshore, are you good with this?
Easier for you if folks onshore are interested.
A little bit.
Yeah.
It's a good idea. Deb? Please, yes, please collect. Okay. Well, we have 2 votes anyway, pilot. That looks like a great one, the one the lasers are on.
Yeah, I can't tell how big it is, but we can give it a shot.
Well, yeah, it might be buried to some extent. The one lower right
like 40
is big too, but that might be looser.
Well, I'm going to set up.
Okay. Whichever one you can get would be great.
So Levi, if
I'll
you
keep
start
an
getting
eye.
close to stuff, you just call a bail, and I'll bail.
Okay.
Here we are sitting on one boulder looking for pieces of another one.
You want probably just throw it in port wing then?
Starboard wing, probably.
Or starboard wing, yeah.
Just time.
Rocks.
Hydraulics are ready for you. Drawer closed.
We are on our 20th dive in 20 days in Lake 3 of this expedition. That is more dives than have ever made on the Okeanos Explorer on one leg of an expedition.
And we're
okay, Chris, there you go for your next mission. Oh my gosh, look at these guys. Look how big they are. You like that one?
Oh yeah. We like that
she says
lot.
Yes. She says, oh yeah.
All of these are beautiful.
Starboard ring ready to go on board when you are.
Heavy though, huh?
Yeah, we're going to look at it for a second.
Okay.
Yeah, outboard starboard.
Very fine sediment, really fine sediment.
Well, some of it's really fine, but there are larger particles.
Yeah, there are larger particles on the
white
surface.
particles.
Oh,
yep.
lovely, lovely, lovely. Where are we going to put this?
Oh, Josh is great. I would put it in the starboard rock box. Let us take a look at this puppy.
Tilt up a little bit.
Ah. Well, it's angular.
Come in tight.
It's got some manganese on it. It looks like it's got some brownish red.
And it has biofuzz.
It does have biofuzz. Let's hope there's some little commensals you can pick off.
All right, come out partial when you're clear.
Nice zoom. Oh, it's going to be interesting measuring this one. It's got a pointy end.
Looks like a good vampire killer.
It does, a stake. Yeah, well, it has the morphology of a pillow fragment, you know, with this sort of triangular shape.
I didn't say pillow. I said
I know
killer.
I know you did. I know you. I'm ignoring you. I'm going geological.
Okay. Okay. Good.
Yeah, it does. I don't know. We'll see.
So, Patty, are we good on the video?
We are great on the video.
Right.
Thank you, pilot. And in the starboard rock box would be just fine.
Starboard and bring it in.
We have 2 rock boxes. One has a lid and one does not. And the rocks that look more competent, you know, harder and less likely to break apart, we will put into the open rock box.
Let me tilt the main HD down.
And this one is very large.
Not sure if it'll help you, but
yesterday's rock weighed 14 and a bit kilograms, which is like
heavy, huh?
30 pounds, and I picked it up.
You did?
I did.